the question before us says, given 2x squared minus 3x plus 4 equals to 0, find x squared plus beta squared x minus beta. Okay, then let's say give us this one. So in this video, I will start with finding. I want this video to be all about, first of all, finding sum and product of a quadratic equation, and then finding sum of roots, sum of products, and product of roots of cubic equation. So let's try to find sum of roots. So we simply do it this way. For quadratic equation, we say that quadratic equation, anytime you have quadratic equation, is an equation of the highest power, whose highest power is 2. Highest power of the variable is 2. So if we have this, it simply means that you have two solutions. So x is equals to alpha and x is equals to beta. So you have that this is the sentence saying x minus alpha all equals to 0, x minus beta all equals to 0. So as we have this now, we can simply say that this can have the same, just single brackets, x minus alpha x minus beta all equals to 0. So by the time we expand this, we can now use it to compare the standard form of a quadratic equation. So x times x is x squared, x times beta is minus beta x, minus alpha times x is minus alpha x, minus alpha times beta is plus, minus beta is plus alpha beta all equals to 0. So notice that here is x squared minus, I can factor these two out. What is common here is x. So I have alpha plus beta. Or you say you have beta plus alpha, whichever way you want to do it. So plus alpha beta all equals to 0. If you carry this times this, you get this. Carry this times this, you get this. So that means that this is the sentence saying x squared minus alpha plus beta or x plus alpha beta equals to 0. So notice that this thing now can be compared to the standard form of a quadratic equation, which is ax squared plus bx plus c equals to 0. So notice that this is x, this is x squared, but we normally say that the power or the highest power of a quadratic equation of a polynomial should have unity, as should be unity, or when we say unity, means should have 1 as its coefficient. So we can say divide both sides, everything here, by a, which will give me x squared plus bx over a plus c over a equals to 0. 0 divided by a is 0. So comparing it now, you will see very well that this is the sentence, this everything here. So let's do it this way. This is the sentence saying here x squared is equals to x squared. Then alpha plus beta x is equals to, this carry minus, so it's equals to everything here, which is bx over a. Then there's no x here, this one is constant. Alpha beta is equals to c over a. So comparing it, we now have that this is the same thing as saying we have x here, we have x here. So x equating it, we now have that this is the same thing as saying minus alpha plus beta is equals to b over a. We are comparing, since we have x and x here, we ignore the x. So this is going to be the same thing as saying, since I have minus here, minus crossing equality sign, alpha plus beta is equals to minus b over a. So simple. Then this one now, alpha beta is equals to c over a. Very simple. So that is how you get the sum and product of a quadratic equation. So alpha plus beta, the sum, is equals to minus b over a. Then alpha beta, the product, is equals to c over a. Very important. C over a. Alright, let's try to do for cubic equation. So we know that cubic equation is an equation whose highest power of variable, let's say x is the variable, is 3. And whenever the highest power of a variable is 3, it means that that variable will have 3 solutions. Root simply means the solution of an equation. So x will be equals to alpha, x will be equals to beta, x will be equals to gamma. So for cubic equation, we assume it to be equals to alpha, beta, and gamma. 3 things. So if you want to use any other thing, no problem, but this is the generally accepted standard. So when we cross this, it becomes x minus alpha equals to 0, x minus beta equals to 0, and x minus gamma equals to 0. So that you now have everything, since everything is equals to 0, you can collect it together. X minus alpha, x minus beta, x minus gamma, all equals to 0. All equals to 0. So finding the roots of a cubic equation, we take it that x is equals to alpha, x is equals to beta, x is equals to gamma. So when you do this, like this one, crossing equality sign, it becomes x minus alpha equals to 0. Cross equality sign, x minus beta equals to 0. This one cross equality sign, x minus gamma equals to 0. So by the time you collect everything, you can say since all of them individually is equals to 0, all of them are equals to 0. And the reason we are saying this, we know that cubic equation is the, let's say the variable is x, is equal a polynomial whose highest power of the variable, in this case say x, is 3. So whenever we have 3, it means that we have 3 solutions. So, and that's what roots is all about. The solution of an equation is called roots. So let's expand. X times x, x squared, x times beta minus beta x. Okay, let's just go as well and times through it. Okay, let's just get to this first. Let's finish multiplying these two before we go here. Now, and then let's do alpha times x, going to be minus alpha x. Then alpha minus alpha times minus beta will be plus alpha beta. So now that we are through with it, bring this one down. X minus gamma equals to 0. So let's go now. This times x squared will give me s cubed. X times beta x will give me minus beta x squared. X times alpha x will give me minus alpha x squared. X times alpha beta will give me plus alpha beta x. So let's go to gamma. Let's go to gamma. Minus gamma times x squared will give me minus gamma x squared. Minus gamma times beta x will give me plus, because there's minus here, plus beta gamma x minus gamma times minus alpha x will give me plus alpha gamma x then minus alpha times alpha beta will give me minus alpha beta gamma minus alpha beta gamma. So at this junction, what we can do at this point is to say, let's collect like terms. So everything with s cube one side, everything with s square one side. So we now see that this is going to be s cube minus beta x square minus alpha x square minus gamma x square. So the next thing is x. So plus alpha beta x plus beta gamma x plus alpha gamma x. So if we are done with collecting x, then the constant, the one without x, minus alpha beta gamma. How to be checking this is count 1 2 3 4 5 6 7 8. Okay, so now that we are through with collecting this, we can now say let's factor out. So this is s cube minus, anytime you want to factor out the value before the first thing there, just bring it out. The symbol before the first value there, bring it out. So minus, what is common here? Sorry, before the bracket, what is common? And x square, x square, x square. So I bring minus x square out. X square, so beta plus alpha plus gamma. So at the time you do this times this, you get this. Minus x squared times this, you get this. Minus x squared times gamma, you get this. So plus, then what is common here is x. So factor x out. So plus x, you get alpha beta plus beta gamma plus alpha gamma. Okay, so we've been able to factor out. We've been able to factor out. So now that we're done factoring out, we can simply say we know that alpha comes first before beta before gamma. So we can say s cube minus x square alpha plus beta plus gamma is the same thing plus x alpha beta plus beta gamma plus alpha gamma minus alpha beta gamma. So you can see that if you compare this with the standard equation for cubic equation, we've gotten what we are looking for, because the standard is the same thing as saying, let's write this to be s cube, I'm coming, alpha plus beta plus gamma, or x square plus alpha beta plus beta gamma plus alpha gamma x minus alpha beta gamma. So comparing it with the standard equation of a cubic equation, we have as cube plus b x square plus cx plus d equals to 0. So and we know that this is supposed to be unity, so we divide both sides by a. So we get x cube plus b over ax plus c over ax plus plus d over a equals to 0. So you can see that x cube is equals to x cube. Then everything here, this is x squared, can be compared to this. So once we are through with this, what we now do is comparing. So we can see that comparing x squared, this is x squared, comparing x squared, it will be the same thing as saying minus alpha plus beta plus gamma is equals to b over a. And notice that this, trying to make this subject of the formula, there's minus here. The minus will cross the equality sign, so that we have, this is the sentence as saying alpha plus beta plus gamma is equals to minus b over a. So what it means is that sum of roots of a quadratic equation is the same thing as sum of roots of a cubic equation. So minus b over a. So now notice for x, everything x can be compared with this. This is x, this is x. And notice that the value is c over a. Here is alpha beta plus beta gamma plus gamma. So I can bring it out. Alpha beta plus beta gamma plus alpha gamma is equals to the value here, which is c over a. So the next one, notice that this is the constant term. This one now, there's no x here and there's no x here. Is it not true? And it's carrying minus. So everything here can be likened to what is here. This is now a mongo. This thing is now a mongo. I'm talking about this. So we can liken the two so that we now get, let's compare it. So that we now get minus alpha beta gamma is equals to d over a. So trying to make alpha beta gamma such the formula, this will cross equality, or you say divide both sides by minus 1. So you now have alpha beta gamma is equals to minus d over a. Very simple. So that there you have it. So this is your sum. So this is your sum of products. Then this is your products of roots. And still remember that what we are dealing with here is roots of a cubic equation. So with that said, we can now go back to the question. Now that we have all the parameters we need, look at the question. The question says, given 3x cubed plus 7x squared minus 2x minus 4 equals to 0, find alpha plus beta plus gamma. So in order to find that, we now know that alpha plus beta plus gamma is equals to minus b over a. And alpha beta plus gamma, alpha beta plus beta gamma plus alpha gamma is equals to c over a. So this is equals to c over a. And then alpha beta gamma is equals to minus d over a. So this one is equals to minus d over a. So now that we know this, how do we get that? Now let's bring out what we are given, the equation we are given. We are given 3x cubed plus 7x squared minus 2x minus 4 equals to 0. So you can now see, we normally say that the coefficients represents the a. The first one is a. Whatever we see there, assuming there is nothing here, it means 1 is a there. So this one is b, this one is c, this is the d. So for that reason, for this alpha, so for I part, which is alpha plus beta plus gamma, to be equals to minus b over a, which is 7. So it's having minus 7 over 3. Very simple. I always advise my students, always leave your answer in fraction. It's better to leave your answer in fraction than decimal points. So I have minus 7 over 3. So let's move to II. II says that we should find alpha beta plus alpha gamma plus. So find alpha beta plus alpha gamma plus beta gamma, and we know that it is equals to C over E from what we've gotten, from what we did here after comparing everything. From what we did here. Then we solved further to get it to be. So what am I pointing? What am I even pointing? Sorry. Alpha beta plus beta gamma plus alpha gamma. This is where we are. And it's having x. We are still here. So x and x comparing. You see that the value is C over A. This is where we are. Sorry, we've not reached the other part. So C over A. And what is C here? Minus 2. It's carrying minus. So we have minus. It's the coefficient we normally use. That's what we call A, B, or C and D. The coefficient. So minus 2 all over. A is 3. So if you like, you can take your own down to maybe decimal points, but I leave my answer the way it is. Once I get fraction, I leave it like that. So for I, which is this part here, they said alpha beta gamma, the product. So alpha beta gamma, and we got from solving the whole equation, we got it to be equals to minus d over a. Minus d over a. And here I have d to be minus 4. D is minus 4. So there's minus here already. So it will be minus 4 all over. A is 3. So it's going to the sentence as saying 4 plus minus 4 over 3. So alpha beta gamma is equals to 4 over 3. Very simple. So now that you know this, there's a trick I like teaching my students. So the simple principle there is that when you want to find alpha plus beta plus gamma, anything sum, all of them, see all of them, even when I'm doing alpha beta plus beta gamma plus alpha gamma, all of them is all over A. Even when I'm doing this 3, they are all over A. So alpha beta gamma, they are all over A. So for this one now, for the sum is always carrying minus B. Then the next thing is C. You can't have A over A because A over A is equals to 1. So it's always carrying minus B first, then C, then minus D. So minus B, C is positive. So it's always going this way. Minus, positive, minus. So, and if you notice, you always have, for cubic, is always A, B, C, D. So it's always going to be B first, C, D. And they are all over A, over A, over A. Whichever one you want to use and remember it, you can use it. Subscribe. Thank you. So we are given 2x squared minus 3x plus 4 equals to 0. First of all, what we have for quadratic equation is always sum and products. And I told you both the sum and product, everything is always over A, over A. Then B, here is A, here is B, here is C. A over A is equals to 1. So we will never have A over A when we are dealing with quadratic or cubic. So it's always going to be B, and B comes before C. So, and you always need to think of it as minus first, plus. So you need to know this. I've taught you how to derive this equation, but if you forget, always remember that B comes first before C. Then you now do evening before morning, which is negative before positive. So now that I know this, I can now progress and see if I can solve this question. Now, let's try to find the sum here first of all from this equation. They did not tell us to find it, but we can first find it. So the sum here will be equals to, this is my 3, B is minus 3, which, and is having minus here. So minus 3, that is B, all over A is 2. So it's the same thing as saying 3 over 2 is the sum. Then the product is going to be C over A, that is 4 over 2, which is the same thing as saying 2. So now that I know this, I've gotten the products. That is, this product is the same thing as saying alpha beta, and then this is alpha plus beta. This is what I've gotten. This is what I succeeded in getting. Now you need to know that everything that is not alpha plus beta and alpha beta, once you are given to find the root of a quadratic equation and you notice that it's just alpha and beta, it's talking about quadratic equation. So once you are given anything that is not alpha plus beta or alpha beta, you need to look for a way to convert whatever you are given to have alpha plus beta and alpha beta so that you can be able to use it to solve. So just like this one, for example, there is no time you can't derive. If you remember how we derived sum and product of quadratic equation, we didn't account for this. There's nothing like this there. So let's try to see if we can convert this to have alpha plus beta and alpha beta. So I will say the I part is alpha squared plus beta squared they are asking me to find. But I'll ask myself, if I choose to do alpha plus beta all square, this is equals to, by the time I interpret this alpha plus beta, alpha plus beta, this is equals to this. On a normal day, we know that in secondary school, when we are solving this, we normally solve this side, and whatever we get, we say is our answer. We cross it and say this is our final answer. But we never realize that what we are trying to say is that everything here is equals to what we've solved on the right hand side. So it's when you are trying to derive this alpha beta, this approach now makes you account for what is on the left hand side and on the right hand side. So this is equals to this. And why am I using this? Because I know that inside this, by the time I expand this, I should be able to get alpha square plus beta square, because I can't use it to solve. So how do I make this alpha square plus beta square to have alpha plus beta and alpha beta? Once I'm able to get it, so that it can be able to be put into the equation to derive the two things that I can always get for quadratic equation, which are the roots of the quadratic equation. Every other thing is not there, but I know that something can give it to me. So with that said, I will now do alpha times alpha is alpha square. Alpha times beta is alpha beta. Then alpha beta times alpha is alpha beta. Then beta times beta is beta square. Now very well you can see that this is the same thing as saying alpha square plus 2 alpha beta plus beta square. So all equals to alpha plus beta square. So if you notice, there's alpha square here, there's beta square here, so I can collect the 2 alpha square plus beta square plus 2 alpha beta, that is this one, equals to alpha plus beta square. So making the subject of the formula, I will now have alpha square plus beta square is equals to alpha plus beta all square. This, everything across equality sign becomes minus 2 alpha beta. So notice that alpha square now plus beta square is equals to alpha plus beta all square, then minus 2 alpha beta. Now notice that this thing now that we have here, this is product of roots of quadratic equation. This is sum of roots of quadratic equation. So when we are asked alpha square plus beta square, we don't need to use this because there's nothing under quadratic equation like this that accounts for this. But we've seen that this thing that is here, alpha square plus beta square, is equals to sum of root square minus 2 times product of roots. So this is the one we use. So we can now come and use this one. So anytime you are asked to find anything that is outside alpha plus beta and alpha beta, all you just need to do is to look for a way to introduce what you can use to find that same value given to you. Then make that value given to you the subject formula. And when you do it, you'll be able to get the sum and roots, or sum and roots, whichever way it comes out. But you don't use it as is given. So I now know that our sum of roots for this equation is 3 over 2. I'll put it 3 over 2 all square minus 2. Product of roots is 2 here. So 2 times 2. So this is going to be minus 4. 3 square is 9. 2 square is 4. I see it all over 1. So if I take LCM 4, this is 9 minus yes. So 4 times 4, 16. So minus 16, which is equals to, if you put 4, 25 over 4. Should be? Yes. Yes, 25. So this is what I will have. So alpha square plus beta square is equals to this. Is equals to this. Very important. So whenever you are given anything that is not alpha plus beta, you go and expand. If you don't understand it, calm down and watch. Listen to what I've said. You understand. Okay. Let's move to the next one. They gave me alpha minus beta. I should find the alpha minus beta for this equation. Let me write it. Alpha minus beta. Notice that alpha minus beta there is not here, because the two things we have for quadratic equation is alpha plus beta and alpha beta. So alpha minus beta is not there. But how do we make this alpha minus beta to have alpha plus beta and alpha beta? That is the goal. Once we see this, we can now say that alpha minus beta should be inside alpha minus beta all square. You must always expand. If I'm giving, in fact, see the principle, the trick there is, if I'm giving, for example, if I'm giving alpha cube plus beta cube, I'll have to do this thing in a way that I will say inside alpha plus beta all cubed, which is equals to alpha plus beta, alpha plus beta, alpha plus beta. I should be able to get this something like this, which I will make subject of the formula. Then if I have alpha minus beta, let's say I have alpha raised to power 4 plus beta raised to power 4. This should be equals to alpha plus beta all raised to power 4, which is equals to alpha plus beta, alpha plus beta, alpha plus beta, alpha plus beta. So by the time I do this, I should be able to get this value, which I will make subject formula, and the others will be able to give me something like alpha plus beta or alpha times beta. So that's the principle. So let's go back to business. So I'll say inside alpha minus beta all square, I should have alpha minus beta. Somebody will say, why didn't you just use alpha minus beta? This on its own is nothing. It's useless because it's not containing alpha plus beta and it's not containing alpha times beta. So I will say alpha minus beta, alpha minus beta. Yeah. Alpha times alpha, alpha square. Alpha times beta minus alpha beta minus beta times alpha minus alpha beta minus beta times minus beta plus beta square alpha square. Okay, all equals to alpha minus beta square. Always carry this sign too. Don't just say it's equals to this. Before you used to do that thing and you forget that it's still equals to the side that started it. So you need to be carrying it along. So minus 2 alpha beta plus beta square equals to alpha square, collect this, plus beta square, collected this way. So minus 2 alpha beta. So alpha minus beta square is equals to everything here. Now notice that we found this before. Alpha square plus beta. We did it here. Alpha square plus beta square. And it gave us alpha plus beta all squared. So I'll replace this one. It gave us alpha plus beta all squared minus 2 alpha beta. That is what everything alpha square plus beta square gave us. So now notice, then I'll bring this one down. So I've replaced this with what is equals to. So minus 2 alpha beta. So they are equals to alpha minus beta all square. So notice that if I collect like terms, this is the same with this. Minus minus will give me minus 4 alpha beta. So alpha plus beta all square equals to alpha minus beta all square. Alpha plus beta all square, then alpha minus beta square. Now notice I've gotten what I'm looking for here. See, I have alpha plus beta. Then I have alpha beta. That is what I'm always looking for. How do I get what I'm given to become alpha plus beta and alpha beta? Now notice I still have my alpha minus beta all square. So I can say take square root of both sides. So I can now have square root of alpha minus beta all square equals to square root of alpha plus beta all square minus 4 alpha beta. Notice I cannot cancel this square with this square root because there's minus. This value is being subtracted from this. So I can't take the square root by doing this one, squaring this one. It's not possible. But this can cancel this. So that I now have alpha minus beta is equals to roots. Watch it. Roots alpha plus beta all square minus 4 alpha beta. So alpha minus beta is equals to roots alpha plus beta all square minus 4 alpha beta. Alright, so let's now solve it. So we are not using this one because it's equals to this, and there's nothing like this in roots of a quadratic equation. Roots of quadratic equation is just alpha plus beta and alpha beta. So whenever we are given anything outside it, how do we convert it to have alpha and alpha plus beta or alpha and beta? So and we've gotten that the alpha plus beta for this equation is 3 over 2. So we put 3 over 2 all square minus alpha beta is 2. Then we have 4 times 2. So take the square root. Sorry, this is alpha minus beta. So this is going to the same thing as saying square of 3 is 9 over 4 minus 8. Take the square root. So alpha minus beta is going to be equals to 1. So 9 times 1, 9. 4 times 8 is 32. Should be? Yes. Minus 32. Because it's 8, 16. Yes, 32. So I all over 4 times 1, 4. So this will be equals to, if I remove 9 from 30, it should be, I have 21. Then put 2 here. It will be 23. 23 over 4. So you get minus 23 over 4. And like I said, I like leaving my answer in fraction form, not decimal. So this is your answer. Let's move to the next one. The next one says alpha square minus beta square. Number 3. So to get alpha square minus beta square, we simply ask ourselves, alpha square minus beta square, this is difference this of 2 squares, that is 1, 2. This is raised to power 2. This is raised to power 2. This is difference of 2 squares. And we know that difference of 2 squares is the same thing as saying alpha minus beta, then alpha plus beta. This is difference of 2 squares. What do I mean? If I have a raised to power 2 minus b raised to power 2, this is a square. This is a square, the difference. So it will give me a minus b, a plus b. And by the time you times these two, you get a square plus ab. Then times this, it becomes minus ab minus b square. So you see that these two will give you 0. So you are left with a square minus b square. So you need to note that. So that is the reason why as I'm giving this, the minute I write it out, alpha square minus beta square is the same thing as alpha minus beta, then alpha plus beta. I know that alpha plus beta, we already have it, which is the same thing as saying minus b over a. But alpha minus beta, we've gotten it. Let's check. We got alpha minus beta to be the same thing as saying roots. Alpha plus beta square minus 4 alpha beta. So we use it to replace it. So we say everything here is the same thing as saying roots. Alpha plus beta all square minus 4 alpha beta. 4 alpha beta. So you replace it, then bring this one down. Alpha plus beta. The reason why we are doing this is that there's nothing to account for alpha square minus beta square in root of quadratic equation. So we always try to use, or should I say we use expansion. We always try to use expansion to solve and get the value. So now that I've done that, I'll come and now looking at this equation, alpha plus beta is 3 over, in this question is 3 over 2. This equation given to us. So we'll put roots. Okay, I don't think we even need to do it because we've solved for alpha minus beta. Alpha minus beta gave us minus 23 over 4. Let's just put that value. Minus 23 over 4. Then alpha plus beta gave us 3 over 2. So just multiply it. Just multiply. So that you have 23, 23, you have 9, then you have 6. So you have minus 69 all over 8. Yes. So if you look at it very well, you clearly see that there's nothing common to 69 and 8. Shebi? Yes, there's nothing common. 9 is an odd number, 8 is an even number, so there's nothing common. So if I do 69 divided by the factors of 8, not even 4 can go, so nothing can go. I'll leave it as fraction. I don't want my answer to be decimal, so it's minus 69 over 8. That's my answer. So let's move to the next one. Next question. Next question says that we should get beta square minus alpha square. Okay, number 4. Beta square minus alpha square. But this thing, if you look at this thing very well, this is the sentence saying beta square minus alpha square. Here we have alpha square minus beta square. They almost are alike. This is also difference of 2 square. But notice that something happens. If I choose to come and see, I can find this on its own. I can say, however I rotate it. But let's just look at it critically. You see that this is the sentence saying minus alpha square plus, minus beta square. Notice that minus times this will give us this minus alpha square. Then minus times this minus will give us positive. So I can choose to write this way. Very important. So you can see that alpha square minus beta square is what is inside here. And there's minus here. So it's the sentence that say minus. Everything will go for alpha square minus beta square is 69 over 8. So minus 69 over 8. Minus times minus is plus. So this is equals to 69 over 8. Very simple. Okay. Let's move to the next one. Is having alpha cube minus beta cube. Alpha cube minus beta cube. Alpha cube minus beta cube. So which means that anytime they give you alpha to be negative, in most cases it's always the other way around. This beta should be negative, but if they give you, you check if there's any way you can factor out the sign, so things will be easy for you. That's why mathematics is something that has to do with people that are somehow sit back, like you observe before you try to start solving. You don't just see a question, you jump into it. So let's go. So notice they've given us another cube, and there's nothing like this under roots of quadratic equation. So we can just say inside alpha minus beta all cubed, we should have something like this inside it. So we use this to be alpha minus beta, alpha minus beta, alpha minus beta. You should remember, whenever something is raised to power 3, you can choose to do it that way. It's even better for me that way. You can say, okay, let's go this way. You can see somebody wants to tell me, but why don't you just come and use all these values for alpha minus beta and replace all of them? I will not do it like that because I need to expand. So there's nothing stopping me from expanding this. It's not difference of 2 squares. And you know there's nothing like difference of 3 squares. So I will do this times this. It will give me alpha square times this. It will give me minus alpha beta. This times this minus alpha beta. This times this plus beta square. I can use binomial theorem. If you remember our binomial theorem, I'm just doing this because I want us to take it step by step. Normally, if I'm doing this on my own, I will use binomial expansion to solve this. 1, 3, 3, 1, 10. put the product raised to power, the alpha will be decreasing, the beta will be increasing in power. So, but let's just continue. We started already. So now that I have this, I've expanded this. So bring this one down. See that this one is stress, doing double job. So alpha minus beta all cube is equals to times this. You get, to be honest, binomial theorem, binomial expansion is the best. So I will get alpha cube. I'm doing this is so that you see it's coming to life. So alpha cube, then times this, you have alpha square beta alpha square beta alpha beta square. This is minus alpha square beta plus alpha beta square plus alpha beta square minus beta cube. So what you need to be paying attention to is the sign, because sometimes that's where the mistake come, the sign. So alpha minus beta all cube is equals to alpha raised to power 3. I'm pulling out this. This is alpha cube. The ones with cube, I'm pulling it out. So minus beta cube. The essence of doing this is, since we know that it's not among the roots of equations of quadratic, we are saying since we are given this, expanding to power 3 should give us that value inside it, and we've gotten it. So now let's collect like terms for the others. So I will now have minus alpha square minus alpha square minus alpha square. How many times did it occur? 3. Sorry, this is alpha square beta, then plus, where again do I have alpha square beta? Okay, another alpha square beta. So let's bring out all the alpha square beta. I have minus alpha square beta minus alpha square beta. Which other one? Then minus alpha square beta. Then what about beta square? So I have beta square. Then I have another beta square. Let's check. How did I get this one? This is when I did alpha minus beta, minus beta times, so you see alpha, see all the hard work, all the stress. This is stress, but when you use binomial expansion, get it simple. So you see I have this is plus, so it's plus alpha beta square. Then you now move to this one, minus so I'll have plus alpha beta square plus alpha beta square plus alpha beta square. So you see that I have alpha cube minus beta cube minus, if you check this, it's 3 of it, so minus 3 alpha beta, 3 alpha square beta, then plus, this is 1 2 3, 3 alpha beta square. Yes, yes, so that's it. 1 2 1 2 3 4 5 6 7 8. Yes, so but okay, so this is alpha minus beta cubed. So trying to make this subject of the formula now, you see that you have alpha cube minus beta cube equals to, this is alpha minus beta all cubed. So this one, cross equality sign, the minus changes to plus 3 alpha beta, alpha square beta, then this one cross equality sign minus 3 alpha beta square. Are you seeing it? So let me write it. This is alpha cube minus beta cube equals to alpha minus beta plus 3 alpha square beta minus 3 alpha beta square. Yeah, you factor out. So you factor out. Factoring out, what is common amongst these two? I'm seeing alpha beta here. Seeing alpha beta here. I'm seeing 3. So I have 3 alpha beta into alpha minus beta. So by the time I carry this and times this, I get 3 alpha square beta. Carry this and times this. Let's carry this and times this, I get this 3 alpha beta square. Okay. So I now have that alpha cube minus beta cube is equals to, notice something. Notice that, yes, I could have as well, yes, I can still find a way to go about it, but I could have as well done, but whichever way you do, yeah, I can still, I'm checking my possibilities. So I could have as well said, assuming this thing is, assuming I put minus 3 alpha beta here, alpha square beta, plus 3 alpha square beta, and factor that I have minus, then plus, okay, it will still be minus, so it's still the same thing. So what I will do here is to say, what I have here, alpha minus beta, all raised to power 3. Alpha minus beta is this. This is what we got for alpha minus beta. Alpha plus beta square minus 4 alpha beta. So this is the same thing as saying alpha plus beta all square minus 4 alpha beta. Then take the square roots. Or everything here is raised to power 3. All raised to power 3 plus 3 alpha beta. Then this is alpha minus beta. And it's the same thing as saying alpha plus beta all square minus 4 alpha beta. Yes, so using this we can now get alpha cube minus beta cube, which is equals to everything about alpha minus beta, we got it to be minus 23 over 4. So minus 23 over 4 raised to power 3 plus alpha beta is 2. So plus 3 times 2. Then, okay, there's no need putting this because I know what alpha minus beta is. Alpha minus beta is the same thing as minus 23 over 4. So you can do it. You can do it. So if you do this, it's going to be here 3 times 2 is 6. So 6 times minus 23 over 4 plus let's try to do this. That's a handful. You see some people sometimes they try to do a lot of abbreviations on this particular one. You have to go all out. So 23 times 23 times 23. So you get 12,167 all over 4 times 4 times 4 times 64. So now 6 times 23 is 138 and it's minus. Here is also minus. So it's minus. So this is going to be minus 138 over 4. So, and there's minus a minus 12,167 over 64. So let's try to find this. Let's try to solve and find the LCM. So the LCM should be, let's go 64 and 4. 64 divided by 4. 4 here, 16, 1. 4 here, 4, 1. 4 here, 1, 1. So 4 times 4 times 4, 64. So the LCM is 64. I'm coming, let me write it. Mm-hmm. 16 times 138. So minus 12,167 minus 2,208 minus 14,375 all over 64. Okay, so I can leave my answer like this. So 14,375 over 64, or I can say that this is equals to, and is minus, it's equals to minus 225. So whichever way you want to do it. So, but remember that what brought us to this is this. So by the time I do this now, let's check. The time I do. Okay, so there you have it. Let's look at the next one. I'm checking if there's something we missed. So let's look at the next one. The next one is alpha cube plus beta cube. So for alpha, number 6, alpha cube plus beta cube. Alpha cube plus beta cube. Alpha cube plus beta cube. So this time I'll use binomial expansion. We know that this can be found inside. If you like, you need to master this trick. Once you're given this, you need to remember that what you have here can be found inside this. And this is the sentence saying, if you remember, binomial expansion. 1, 3, 3, 1. So that we now have alpha raised to power 3. Then beta raised to power 0. Then alpha raised to power 2. Beta raised to power 1. Alpha raised to power 1. Beta raised to power 2. The powers are increased. The powers will sum up to 3 in each case. So alpha raised to power 0. Beta raised to power 3. So this is going to be alpha raised to power 3 plus separating them in each case plus, so plus 3 alpha square beta plus 3 alpha beta square plus beta cube. Yes. So all this while that we're running around, you see that once you use binomial expansion, you're getting the sentence easier in a faster way. So alpha plus beta all cube. So you see that this is the sentence I'm saying bring these two. You see, so I get alpha cube plus beta cube plus 3 alpha square beta plus 3 alpha beta square. Go and watch my video on binomial expansion if you are not understanding what I did here. So you see that making the subject of the formula now, we now have alpha cube plus beta cube is equals to alpha plus beta cube all cubed. This one crossing over minus 3 alpha square beta crossing over minus 3 alpha beta square. Alright, now notice something. This is the sentence I'm saying factoring out alpha plus beta all cubed minus 3 alpha beta is here. 3 alpha beta is here. So 3 alpha beta all into alpha plus beta equals to alpha cubed plus beta cubed. So notice that here I have plus. So notice that what I have here now is 3 alpha beta. 3 alpha beta times alpha is 3 alpha square beta. 3 alpha beta times beta is 3 alpha beta square. So that means that alpha cube plus beta cube is equals to alpha plus beta all cubed minus 3 alpha beta, then alpha plus beta. Remember that the whole idea is always how do I make whatever I'm given to contain alpha plus beta and alpha beta. So that is what I've gotten here. So I can now substitute. Notice that in the question, alpha plus beta, we got it to be 3 over 2. So let me replace it. So I have alpha cube plus beta cubed to be equals to 3 over 2 shebi raised to power 3. Yes. Then minus 3 alpha beta. And alpha beta in this question is 2. So minus 3 into 2. Then alpha plus beta. Alpha plus beta is 3 over 2. So if you do this, it's going to give you 3 times 3 times 3. That is 9. Should be? Yes, 9 times 3. So that should be around 27. Yes. I ought to be correct. 3 times 3 times 3. Sorry, 3 times 3 times 3. That is 3 times 3, 9 times 3. That should be 27. Yes. So 27 all over 2 times 2 times 2. That should be 8. So minus 3 times 2 is 6 times 3 over 2. So this is the same thing as saying Koyeboyara. Who be this? I have 6 times 3, 18. So I have 18 over 2 minus 27 over 8. So equals to 2 can go here 1, 2 go here 9. Okay, so I have 27 minus 9. 27 over 8 minus 9 over 1. And if you do this, you have go here 27. Go here 9 times 8 minus 72 all over 8. Or you do it 8 here, 27. Then 8 times 9. Yes. So 27 minus 72. You get minus 45 all over 8. So minus 45 over 8. So alpha cube plus beta cube is giving us minus 45 over 8. I just hope there's no mistake. So let's check. 3 over 2 cubed. The 3 times 3 times this. So minus 3 times 2. Then we have this. So we did everything. 3 times 6. More like 6 times 3. Yes. Alright. So let's move to the next part. Next one says that we should find 1 over. So let me write it. I have number 7. 1 over alpha minus 1 plus 1 over beta minus 1. So I have finding the LCM. This is alpha minus 1, beta minus 1. You carry this and come here. You have beta minus 1 plus alpha minus 1. So you very well see that this is the same thing as saying alpha plus beta minus 1 is minus 2 all over. Expand this. So you have alpha times beta is alpha beta. Alpha times minus 1 is minus alpha. Then minus 1 times beta is minus beta. Then minus 1 times minus 1 is plus 1. So you get alpha plus beta minus 2 all over. Alpha beta, there's minus here. So minus alpha plus beta. because when this enter this bracket, it changes to minus 2 plus 1, which is what we are looking for. So we can now substitute our values for the equation. Alpha plus beta is 3 over 2 in that equation. 3 over 2 minus 2 all over. Alpha beta is 2 in that equation, so minus 3 over 2 plus 1. So when you get the LCM of this, it will give you 3 minus 4 all over 2. Should be? Yes, then over good. So I have over 1 over 1. So this should give me 4 4 minus 3 plus 2, and that will be equals to, let me complete it here. That should be equals to, it is LCM 2. Do your own. Is the LCM. Okay. So I have 3 minus 4. I have 1 over 2 up there at the numerator. That is 3 minus 4 over 2. So minus 1 over 2 all over 4 minus 3 is 1 plus 2, 3. And everything here is over 2. Everything here is over 2, the LCM over 2. I took the LCM of this and I took the LCM of this. So 3 over 2. So everything here is equals to minus 1 over 2 times 2 over 3. Times 2 over 3, which is the sentence as saying minus 2 over 6. 2 here 1, 2 here 3. So equals to minus 1 over 3. So the value, that is 1 over alpha minus 1 plus 1 over beta minus 1 is equals to minus 1 over 3. So 1 over alpha minus 1 plus 1 over beta minus 1 is equals to this. So that's what you get. So let's try to look at the next one. Remember, this is where we started. Sometimes as you are watching, you carry paper and be solving your own. So as we did that LCM, calm down and get your own LCM. Alright, let's move to the next one. We have 1 over alpha square plus number 8. Then 1 over beta square. This is the question we are solving for. So we do LCM of this will be alpha square beta square. So when this go here, it will be beta square remaining. Here it will be plus alpha square remaining. So this will be equals to, this is equals to, so this will be equals to alpha square plus beta square all over. Alpha square times beta square is the same thing as alpha beta all square. Multiplication is distributive. So alpha square plus beta square, we've gotten something like that before. Alpha square plus beta square, we've gotten something like that before. Alpha square plus beta square, yes, gotten it before. So we got it to be, when we solved, alpha square plus, yes, beta square, we got it to be alpha square plus beta all square, alpha plus beta all squared minus 2 alpha beta. all over alpha beta square. So we can just say alpha plus beta in this question is 3 over 2 square minus 2 alpha beta is 2 all over 2 squared. So this will give me 9 over 4 minus 4 all over 4, which is equals to 9 minus 16 all over 9, 4 times 1, all over 4 over 4. So 9 minus 16 is the same thing as 7. So 9 minus 16 is minus 7. So minus 7 over 4 all over 4. And this should give me minus 7 over 4 divided by 4. Yes. This should give me because everything there is the numerator. Everything here is the numerator being divided by this. Don't mistake it. So this will be, I've taught you, I've sent videos on this to know when it's different. So this should be minus 7 over 4 times 1 over 4. This will be the same thing as saying minus 7 over 16 as my answer. Don't confuse it. When I have A over B divided by C, it is different from when I have A divided by B over C. Here a whole number is being divided by a fraction. Here a fraction is being divided by a whole number. This will be equals to A over B times 1 over C. This will be equals to A times C over B. Alright, so there you have it. Let's move to the next one. Next one, so there you have it. We are in number 8. So let's move. That means that we've gotten number 8. 1 over alpha square plus 1 over beta square is equals to minus 7 over 16. So let's move to number 9, which is alpha over beta minus beta over alpha. So this will give me LCM. And you know that beta alpha is the same thing as saying alpha beta. So if you come here, it will be beta. When you come here and hit this, when these two come and hit this, beta will get out. So you have alpha square. Sorry. So alpha beta divided by beta is alpha. Alpha times alpha is alpha square minus alpha beta divided by alpha is beta times this is beta square. So you see that this is the same thing as saying alpha square minus beta square. So and notice that we've gotten something like alpha square minus beta square. Alpha square minus beta square. Let's check. What did we get for it? Alpha square minus beta square. Difference of 2 square. So it should be somewhere here. Wait. Yes. Alpha square minus beta square. We got it. This is what we got. So let's replace everything there with this value. So this will be roots. This will be roots. Alpha plus beta all square minus 4 alpha beta and alpha plus beta. all over alpha beta. So this is what we have for this. So let's now substitute. We know that in this question alpha plus beta is 3 over 2. So 3 over 2 all squared minus 4. Alpha beta is 2. Then this one is not part of the square roots, so you'll be aware. So this is all, take the square roots, then times, so everything here is this way, then this way. So 3 over 2 this way. So everything over, so everything here over alpha beta is 2. So this should be the same thing as saying I want to continue it here. This is 2 a.m. So I'm trying to be fast so I get my sleep. So this is 3 raised to power 2. Can you hear me? So 3 raised 3 squared. Remember that. So we're going to be 9 over 4 minus 8. So if you do the LCM, 4 times 8 is 32. So 9 minus 32 all over 4. Very disgusting type of setup. I don't like the setup of this quadratic equation. So minus 23 over 4. Take the square roots. Wonderful. Okay. So and notice that if you do this, yes, okay, wait, yes, 9 over 4, yes, then we've gotten this. So if you do this, there's 3 outside here, 3 over 2 outside, so times 3 over 2 all over 2. And notice that this is going to be the same thing as saying, let's just do the square root and see what. Notice that this is a negative value. Is this not a negative value? This is a negative value. Let's check something. I think we've come across something like this before. How did we go about it? Okay, it's like all these ones didn't have that particular sign. Okay, so that means that I'm simply left with, I'm going to be left with this, because this is negative value, so I will simply leave it as root 23 over root 4i, then times 3 over 2 over 2, which gives me this should give me 3 over 2 root 23 over 4i. And notice that this can also be the same thing as saying 3 over 2 root 23 over 2i all over 2. Yes, all over 2. And notice that this can be the same thing as saying 3 root 23 over 4i all over 2. Okay. I'm trying to see if I can go further. Imaginary world. We are in the imaginary world, so I'm trying to see that I don't make us enter trouble. So this is the same thing as saying 3 root 23 I over 4. Everything is being divided by 2. Divided by 2 over 1. And this is something as saying times 1 over 2. So this can be the same thing as saying 3 root 23I over 8. Check it. Over 8. Okay, so let's look at the next question. Next in line. So the next question is this and this. But this one we've solved. Remember, we've treated this one. You will take this one as your assignment. So the last one I'm solving is this one. So 1 over alpha square minus 1 over beta square. This is going to be the same thing as saying alpha square beta square. And this is the same thing as saying alpha beta all square. When you carry this and multiply this, you get alpha beta square times this divided by this will be beta square alpha square. So this is going to be alpha square minus alpha square plus beta square. So check it out. You see that alpha square times this, it becomes minus alpha square. Then minus times, so minus times minus will give you plus beta square. So this is going to be minus, and we've gotten alpha square minus beta square before. What did we get alpha square minus beta square to be? Alpha square minus beta square. For this equation, what did we get it? Alpha square beta square. Okay, alpha square minus beta square. And even we've gotten something like that. Minus alpha square s minus beta square. We've gotten it to be 69 over 8. So this is the same thing as saying everything here is 69 over 8. Over 8. All over alpha beta in this question is 2. Go and look at the question. Start from the beginning. So all square. This is the same thing as saying 69 over 8 all over 4. This is the value for alpha minus alpha square minus beta square. So all being divided by 4. So this is the same thing as saying 69 over 8 is divided by 4. So this is the same thing as saying 69 over 8 times 1 over 4, which is equals to 69 all over 32. Okay, I can go further to divide, but I told you I like leaving my answer in fraction unless it's extremely big. So 69 divided by 32. So I have this as my answer, or I can say 2.2. So that's it. There you have it. So remember to like, share and subscribe.